Okay, in this video, I'm going to cover the quiz 9BC. Okay, now let's see question 2. After read this question, right, you will see this is a linear model, right? Linear model. You see there are some keywords like a linear read. It's kind of give you a hint. This is a linear model, right? Now let's see A, what they asked. Use a model to predict the life expectancy of a child born into 2013 round to the nearest tens. So what is the T? You see here, where E represents the life expectancy, right, of a child born T years after 2000. So T means how many years after 2000, and A, we want to predict the life expectancy, right? Expectancy of a child born in 2013. So that means the T is 13, right? Because 2013, it is the 13 years after 2000, right? After 2000. And you know the life expectancy will become bigger and bigger because the quality of life is better and better, right? So it's growing. This one is a linear model, and it is growing. All right, it's growing like this. Anyway, for this question A, you just plug t equal to 13 into the function. You will get E equal to 0.18 times 13, then plus 77.16. And you can use a calculator, right, to calculate this value. Let me use my calculator. I just Google it, alright. 18 times, when you type it, use this sign, represent times 13, alright, then plus 77.16. You see here, what's going on? 77. Why this value is, you see here, it's 0.8, alright, no, it's right. It's a 79, right? It's a 79.5. Right, so this answer is a 79.5. Year is a tenth. Even we didn't ask you round to the. If we don't ask you round to the nearest tenth, you should keep 79.5 also, because this is the exact, right? Exact data. So just keep that. Alright, let's see. Question 3, B and C. What we ask? The same model, right? The same model. Just B, the final y-intercept of the model and explain its meaning in the context of the problem. So the y-intercept is 77.16, right? But don't forget to explain the meaning, right? Don't forget to explain the meaning. Since this question we ask you explain the meaning also. So do not just write a number there. Many of you guys just write a number. Okay. This means this is the y-intercept. You see, another term we use is the initial value, right? Y-intercept or the initial value, and initial value. And here, the meaning in the context, this means the life expectancy, right? The life expectancy born in 2000 is 77.16, right? This means the life expectancy. The life expectancy of a child born in 2000 is 77.16. So that means if a child is born in 2000, then we should expect this child live to 77. Live to 77. And you can see If t equal to 1, that means a child born in 2001, right? 2001. You plug t equal to 1 here, you will get it's 77.18 plus 6, gonna be 34. This means the child born in 2001, the life expectancy should be 77.34. What is the rate of the change in the model? So rate of the change is going to be 0.18, right? Actually, if you have the unit, it's going to be 0.18 years, right? 0.18 years per year, something like that. So here you can skip the unit. The unit is not that important, but actually, if you use the units, it looks like this per year. So the meaning is the life expectancy increases 0.8 years, right? Years after 2000, right? After 2000. Okay. Question 4. You see here, you should use this formula y equal to q0, which is the initial value times this. You see, start from question 4 is exponential, right? Exponential model. Plus 2%, 0.02, and then to the t's. Right? This should be the model, right? This should be model. But here, the t, is 20 years because from 2000 to 2020 is 20 years. So here you can change t to 20. Change t to 20, and then you change q0 to 40,000, right? 40,000 times 1.02 to the 20s. You just put this into the calculator. Let's see. Put this into the calculator. You this. Let's use 1.02. To the 20th power, use this one, use this sign, right? Then to the power, to the 20th power, parentheses, and then times 40,000. Right now you get the value, right? Get the value which is 59347. I didn't remember. Let's check the answer again. 437. Right, 437. So it's 437, and then the answer gonna be wrong, right? Because they're gonna ask you nearest dollar, right? Nearest dollar. Let's see the answer again. You see, after decimal, it is 8, right? It is 8, so you should round up. So it's gonna be 433, 38, right? 438, and now 437. Next question, similar to this one, somebody made the similar mistake. Round to a round number. This one, the correct answer is 4,271. Somebody get 4,272, which is wrong, I think. Alright, now let's see question 6. Question 6, the model, this is the rate, right? This is the initial value, so y equal to q0, which is initial value, times 1 plus the rate. This is the 0.2, right? 2% is 0.02, and 20% is 0.2. So 1 plus 20% of 0.02 to the t's. Let's simplify it. So it equals this, and times 1.2 to the t's. Since you cannot type, right? So manually you cannot type in this form. Then what you're gonna do? Then you type like this: 1.2, right? 1.2. Here you can times. Use this sign, alright? Use this sign. This sign, it means the exponent. Right, it's the exponent. You see here, online calculator, you can see this sign also, right? You see here, exponent, you're gonna use this sign, right? Okay. If you type you know, if you don't use this sign, I count you as right also. This is A is get model. B it will use the model to create part A, calculate population in 15 years. So this one just plug t equal to 15, right? Plug t equal to 15 into this model, alright? Then you will get the value. I'm gonna skip the calculation, but the value gonna be 385,176. Again, somebody didn't get a correct value, like very close to this one, but didn't run to the right number. And somebody used different units. Somebody used dollar. Unit the people. Right? Okay, number 8. Number 8 actually using the same model, right? We just get some data of this model, right? You see the first year is so many, and the second year you just plug everything. You see 1.2 to the t's. Plug t equal to 0, you get this value, right? T equal to 0. You plug t equal to 1, you will get this value. Then plug t equal to 3, you will get this value. And plug t equal, and this is t equal to, t equal to. Then plug t equal to 3, alright, and so on, alright. You will get all the values. Here I just write all of them. So this is 30,000. Next one, 36,000. And then 43,200. And then 51,840. And last one, 62,208. And number 9 is draw the graph, right? Draw the graph. I'm gonna draw the graph here. So let's get to the horizontal line. You'd better use the ruler, right? You'd better use the ruler since I draw it on the screen and don't have a ruler. So draw it by hand. But for you, you draw it on the paper, use the ruler, okay? So 1. This is 3, 4, 5, 2, 1. Here. Those are the years, alright? Those are the years. Years. Label the unit. And now let's get to those are the people in Solent. Alright, those are people. Let's say in Solent. Alright, the value is k. So here let's put it 1, 2, 3, 4, 5. Make it longer. 6. 6. Mean population in Solent. So this is 3,000. This is not 30. Alright, 30 is 60. Is 20, 10, 40, 50. So year 0, it is 250. 25,000. It's here. And then year 1 becomes 30,000, so it's here. And after 2 years, become 43 and 200 for 3,200, so around here. And no, what's wrong? Oh, I didn't put the year 2. Year 2, it should be 36 around here. And the year 3, 43 around here. And year 4, 51 around here. Year 5, 62. So here. You see, it's not straight line. It's not straight line. You connect them. It's not straight line. It'll be curve, right? It's gonna be increase faster and faster like this. It's a curve. You see the problem you guys have? Some of you guys have. And this is good. This one is good. You see, this one didn't connect the points, so it's not a line. This one is good. This one. What's wrong? You see here, when the t equal to 5, it's 70 something. It's wrong for sure. The graph is good generally, but you need to make sure it's clear. And 0 to 1, this part, 0 to 1 too small. Okay, this one, the value looks correct, just the graph is ugly. Didn't use the ruler. All you guys should use ruler. This one use the ruler for sure. You see here, this one perfect. This one straight line. You see, give me a straight line. It's wrong for sure. Even it looks like straight line, but actually it's not. It's not straight line. And here, year 1, 2, 3, 4, 5, no year 0. And this one does not start from 0. You see here, the value it does not start from 0. This one is good. Does not start from 0 also, but looks better. This one I don't know this part. This part it kind of goes up faster than that. This is the big problem. Why? Because your 0 and 1 too close. That's the problem. Okay, that's for this video. Alright, that's for this video.